Today I want to look at this example of a differential equation, and I want to solve it using Laplace transforms. So I have y prime minus y equals 1 plus t to the et power, and it's an initial value problem. We know that y of 0 is 0. Alright, so what I want to do is I'm going to take the Laplace transform of everything in this equation. So the Laplace transform of a derivative, you can write as s times the Laplace transform of y minus whatever happens at y of 0. Okay, so that would be the y prime. Then you have minus the Laplace transform of y, which is ys. And then on the right-hand side of the equation, you have the Laplace transform of 1, which is 1s. And then the Laplace transform of t e to the t, we have to use a translation. So I know that the Laplace transform of e to the at f of t is whatever the Laplace transform would be, but we replace s with s minus a. So here, since I have e to the 1t power, that's going to be the Laplace transform of t, which would be 1 over s squared, but I need to replace that s squared with s minus 1. So I have 1 over s minus 1 squared. All right, from there, I need to solve algebraically. That's the beauty of Laplace transforms, and now I only have to use algebra to solve this. I'm going to have y over s times, so this is a 0 from my initial value. So I have y over s times s minus 1 equals 1 over s plus 1 over s minus 1 quantity squared. So when I divide, I have 1 over s times s minus 1 plus 1 over s minus 1 cubed. Okay, from there I need to be able to do inverse transforms. So it looks like this first guy I might have to use partial fraction decomposition on. This second guy here, the 1 over s minus 1 cubed, I think I can recognize from that it's a translation of something else. So I think that one's going to be okay. Let's do the partial fraction decomposition on this guy real quick. So what I know is I want this 1 over s minus 1 to be a over s plus b over s minus 1. Okay, so if I cross multiply both sides of this equation, I have 1 equals a times s minus 1 plus bs. All right, now if s equals 1, then I get, just plug everything in, I get 1 equals 0 plus b, or 1 equals b. Okay, if s equals 0, then I get 1 equals negative a plus 0b. So there I have it. So this guy, we could rewrite this whole expression then as negative 1 over s plus 1 over s minus 1 plus 1 over s minus 1 cubed. Now this, remember, is my y of s. Okay, so now to get my y of t, I need to do the inverse transform of these guys. So in other words, it's kind of like antiderivatives or something. I need to think about what kind of things gave me these when I took the Laplace transform of them. So I get y of t equals the inverse transform of negative 1 over s would just be negative 1. The inverse transform of 1 over s minus 1 is just e to the t power. Okay, and you can use tables of transforms. You should know these basic ones if you're in a differential equations course. This last one, in order to do my translation here, what I would need in the numerator is, see, I'm recognizing that that this is going to be t to some power, and that power is going to be 2. So I need a 2 factorial over here, which is 2. And to compensate for that, I'm going to put a 1/2 out front. So here this is 1/2 t squared. All right. But I had to put a translation on that. So I'm using this theorem here. So that's going to be times e to the t. And there's the solution of my differential equation. All right. So understanding how Laplace transforms work can really help simplify your work, because you're turning calculus into algebra. And once you handle the algebra, you can just invert it back to get our solutions. If you have any questions on this, let me know, and I'd be glad to help. Thank you.